Hello, welcome to Math with Beth. And we are going to go over limits today, specifically using the difference quotient. So it is a special formula, and you're going to learn more and more what this formula gives. But today we're just going to go over the basics. So this is a special formula called the difference quotient, but using it with the limit at 0, it helps you find something called the derivative. So this is the introduction to derivatives. So using this fancy formula, if we get that new equation, it's called the derivative, and the derivative is an equation that gives you the slope at any point on the graph. So let's see how to use it. So eventually you will find shortcuts for this, but when you first are introduced to derivatives, this is what you're going to need to use. So this is the equation. So using this equation with our f of x, we say the limit as h approaches 0, because that's just always there until we do the limit part. F of x plus h just means go to your equation, and instead of the x, so instead of x squared, you need to plug in x plus h. So this is this part. Minus f of x just means your equation the way it started. So here's the f of x plus h minus here's the f of x, always divided by h. Now, if I did the limit right now, I would plug in 0 and I would get 0 in the bottom of a fraction, which is undefined. So I do not want to do the limit until I can make this as nice as possible. And hopefully that h in the denominator will go away. So to reduce this, most people mess up here. X plus h squared really means this. So I'm going to need to FOIL that all the way out. So I'm going to FOIL and get x squared plus xh plus another xh plus x squared. So this is just me FOILing this out. Now I can cross out the two x squares. These two xh's can be combined. And so now we're here and we still have not done the limit part. But again, if I do the limit right now, I get a 0 in the denominator. So I'm going to try to use one of my methods to reduce this. And in this case, factoring would definitely help, because if I factor out the h that both things have, I can reduce it. So now I'm just going to take the limit of 2x plus h, which means I can go ahead and plug in the 0 for the h and get 2x plus 0, or just 2x. So that is my f prime, they call it, which really means the derivative. So we just found the equation of our derivative, which means if I plug in a number into this equation, what I'm getting is the slope of the original equation at that point. So that takes a little getting used to. But right now, it just asked us to find f prime of 3 and f prime of 4. So the directions were to find f prime, which we just did. Now f prime of -3. So we're going to do that by plugging in -3, and then f prime of 4. So plugging in -3 gets us -6. Plugging in 4, we get 8. So now we've answered all of their questions. So let's try that again. New equation this time, but I'm still going to use that formula, because I'm assuming that if you're doing this, you have not learned the shortcut methods yet. So this is the difference quotient. So now, using our new f of x, 3 over x means for here, I'm going to do 3 over x plus h. So again, remember, I'm just plugging x plus h in for the x, minus f of x in this problem is 3 over x, all over h. So again, if I tried to do the limit right now, I'd have an issue because of that h in the bottom. So I'm going to try to reduce this. So the first thing I'm going to do is on top, I'm going to get a common denominator. So this equation will need x in order for them to both match. This equation will need the x plus h. So we now have 3x over x times x plus h minus, I'm going to go ahead and distribute this, 3x plus 3h all over the common denominator, still all over h. But what I can do now is turn this whole top part into one fraction because I have a common denominator now. I just need to be careful with the negative because this negative technically goes to the 3x and it goes to the 3h. It goes to everything after it. So 3x minus 3x minus 3h can all go together now over my common denominator. And now I can even rewrite this by using the keep, change, flip method. So keeping the top fraction the same, changing it to multiplying, and flipping the bottom fraction. So this is my top fraction. Instead of dividing by h, I'm going to multiply by 1 over h. You always have that option with fractions. Instead of dividing a fraction by a fraction, you can multiply as long as you flip the second fraction. So now that I can do this, I'm going to reduce some. Those go away. I technically have just a 3h on top over here, negative 3h. So I can even wipe out my h's now. And so I end up with negative 3 times 1, so negative 3 on the top, x and x plus h on the bottom. So now I can go ahead and do the limit, which means try plugging in 0 and see what you get. So finally applying the limit, I would get this, which turns into this. So this is my derivative. So f prime of x equals this. So now if it wants f prime of 2, I'm plugging 2 into my new formula to get negative 3/4. Okay. Last question. This is a very standard question in calculus. Once you learn how to do a derivative, they're then going to ask you to find the equation of the tangent line to the graph of f at a certain point. Here are the steps you can always do to answer this type of question. So if we want an equation of the tangent line, we're going to want to know the slope at that point. So that's what the derivative helps us with. So again, you're going to have a shortcut for this soon. But for now, I'm just going to use our difference quotient. Here's my f of x. So remember the formula. We're first going to need to do the limit as h approaches 0 of f of x plus h, which means plug x plus h into your equation wherever the x was, then minus f of x. So minus the equation the way it started, and in my case, that involves another negative. So first I plugged in x plus h minus the function the way it started. All over h, which is a problem, so hopefully the top will reduce nicely. For my order of operations, I need to deal with this square first. So I'm going to keep that negative 2 by itself for now. I'm going to go ahead and do x plus h times x plus h again. So we did this a minute ago. So hopefully you're fine that that would eventually get me to here. So I skipped a couple steps here because we did that a minute ago. Minus a negative, so I'm going to go ahead and call that a plus, 2x squared all over h. I'm still just reducing this as nice as I can and hopefully things will work out. So yes, I have some reducing I can do, and the things that are left all have H's. So I'm going to use the same factoring trick we used a minute ago, and I'm going to factor out an H from both things. That allows me to get rid of the issue, which is that H in the bottom that we never like. So now I finally have a nice enough problem where I can go ahead and take the limit, which really just means plug in that 0 since it's going to work out nicely. And we get negative 4x. So the equation of the tangent line, my F inverse, is negative 4x. But that's just step one. So first I found my equation of the tangent line, but now I'm going to go ahead and plug the a in, which means whatever x value they wanted you to focus on. They wanted us to focus specifically when x is 1. So I'm now going to plug in 1. And that means that is the slope of my tangent line. So again, this will be a lot faster when you learn the shortcuts. But the steps so far have been find the derivative, which was a lot of work for now, plug in the value they gave us, and that is your slope. So now I have the slope, but I also need a point, and all we have right now is an x value. So the next thing I'm going to do is find f of a, meaning plug in that x value to the original equation to get the y. So f of 1, since that's the x value they want us to focus on, would be this, which means 2. So right now we have our slope, so we have our m, and we have a point on the original graph because when x was 1, we plugged it in and got negative 2. So if you have your slope and you have a point, you can always find the equation by using whatever form you want, but when you have the slope and a point, the easiest way is to use the point slope formula. So y minus the y value, which in this case is negative 2, the slope times x minus the x value. And if they don't specify what form they want the equation, you can really stop right here. I just went ahead and made the two negatives turn into a plus. So this is the equation of the line that would be tangent to this at x equals 1. And again, the more you do this, the easier these steps will be, especially when you learn the shortcut to the derivative, because that's what really took the longest. So this is your introduction to derivatives using the difference quotient. If you have any questions, let me know.